In one of our previous lectures, we have already seen how to find out all the prime numbers in a given range. Now, in this lecture, we are going to write a program to find out all the numbers in a given range by using a function. So let's get started. Before we write this program, let's discuss what all functions we'll be creating for solving this problem. So we are supposed to find all the prime numbers in a given range. So first of all, the function that we will be needing is to check if any given number is prime or not. Okay, so we are going to write a separate function to check if a given number is prime. So in that case, the input is the number n. Okay, let's say I would like to check whether the integer number n is prime or not, right? So we have already discussed the logic behind it. How do I check if n is prime? Okay, so what I do is I'll start dividing n by numbers starting from I equals to 1 to n, and then I'll note down all the factors of n. Okay, if I find number of factors to be equals to 2, that means the number is prime. In other cases, if the number of factor is more than 2, that means that number n is not a prime. So this is the logic behind checking whether the number n is prime or not. Okay, this will go into the processing part. And what would be the output, right? So what would be the return value of this function? Okay, so if the number is prime, let me return the integer number 1, indicating that number is prime. So I'll return 1. Okay, I'll write return 1 if prime, else I'll return 0. So the output type is integer because I'm actually transferring the integer value. I'm returning the value 1, indicating that number is prime, and whenever the number is non-prime, I'll return 0. So return type would be of type integer, int. So this is the first function. Okay, let's try to give the prototype, the signature for this function. So as we have already discussed, the return type would be integer, okay, int. So now here I need to give the name of the function. The function actually is checking whether the number is prime or not. So I'll write check prime. Let this be the name of the function. And what is the input for this? What is the argument? There's just one argument, that is the integer number. So I write int. Okay. So this function will actually take one integer input, that is the number n, for which I need to check whether that number is prime or not. And it will return one integer value. It will be either 0 or 1, 0 indicating non-prime and 1 indicating prime. Now let me write a function to check if a number is prime. Okay, so I'll just copy my prototype here, and then I just remove the semicolon. Okay, and then this is how I open the braces. So this is my function definition. So I'll write it down here, function definition. So the input is the integer number n. So I write int space n. So in the definition, I need to give the name of the variable as well. So here I'm going to check if n is prime. So how do I check if n is prime? I'll have to catch hold of all the factors of n. So let me assume that initially number of factors of n is 0. Okay, so I'll have to run a loop. So I'll have to initialize the variable I for running the loop. So I'll run a for loop for I equals to 1. Okay, and I less than equals to n. I'll keep on dividing up to n. Okay, each time updating the value of I by 1, and then I'll have to divide n by I. So I write n mod I and check the remainder. If the remainder happens to be 0, that means I divides n. So in this case, I'll write it as a comment. I is a factor of n. So in that case, what I do is I'll add up to the factors. So I'll write number of factors that I've received is one more than the previous one. So I do factors plus plus. After the loop, what I do is I'll have to check if number of factors is equals to 2. That means if number of factors are exactly equals to 2, that means the number is prime, right? So this is a prime number. Okay, else the number is not prime. Okay, else number is non-prime. So we have already discussed before, if the number is prime, I'll have to return what? I'll return the integer value 1 if number is prime, and if it is non-prime, I'll have to return 0. Okay, so this is the function definition of check prime. Okay, it will take one number n and check whether that number is prime or not. Okay, so it will work on a single number, but our objective was to find all the prime numbers in a given range. Okay, so I'll have to define one more function to find all the prime numbers in a given range. Now we know how to check individual number is prime or not, but now I need to check whether a given range of numbers are prime or not. I'll have to make use of this function that I've defined to check whether the number is prime or not for all the sequences of number in a given range. So how to find all the prime numbers in a given range? What would be the input for that? So the input is the lower limit L and the upper limit U, right? So the lower limit, let's say, is L, and the upper limit is, let's say, U. So this function has two arguments. The first one is the lower limit or the initial value, and the second argument is the upper limit or the end value. Okay, so I have two arguments. Both of them are of integer type. What I do in the processing is very simple. For all these numbers from the lower limit L to the upper limit U, I'll have to check if each of these number is prime or not. Okay, so how do I do that is I'll make use of here I'll make use of the check prime function. So how do I achieve this is by making use of check prime function for all these numbers starting from L to U. What is the output or what is the return type? I do not return anything from this function. I just want to display all the numbers that are prime in a given range. So I'll have to have a return type as void. Okay, so let's give the function prototype here at the beginning. I'll write void is the return type. Let's say name of the function is all primes. So all underscore primes. Okay, what is the input? There are two inputs. One is the lower limit. So I just write int. I just need to give the data type name here. I can also give int a comma int b, no problem, but this is not required. Variable name is not required in the prototype. And one very important thing in the prototype, you have to have a semicolon. It's a declaration, so you have to give a semicolon at the end of this prototyping. Okay, so this is the prototype. Let me just copy this prototype because I need to define it now. Okay, so let me define it after this check prime function. So this is the end of check prime function. This is the end of check prime. Now here let me just paste this prototype and then remove the semicolon. Now I'm defining this all primes function. Okay, so this is a function definition. So this is my second function. Now what I do here is I have two arguments, so I need to give the name of the argument also, variable int l lower limit and int u upper limit. So these two values will be given to me from the main function. So I'll have to find all the prime numbers in this range. Okay, so what I do is I'll have to run a loop, obviously. So I'll have to have a variable I for running a loop. So I'll run a loop starting from I equals to L to I less than equals to U. So I have to run the loop for each of these numbers from L to U. Okay, so what do I do in the loop is very simple. Now I would like to check if I is prime. How do I check if I is prime? I'll have to use check prime function, right? So check prime function is very simple. I'll write check prime. I've already defined this. Okay, and then I'm checking if I is prime. Okay, so this will give me back the answer. Let me store the answer here in the variable ans. Okay, so I'll have to declare this variable ans here in the function itself. Okay, now what I do is my answer would be either 1 or 0. If it is 1, that means I know that number is prime. If it is 0, that means I know that number is non-prime. Now I need to look at the answer and then decide whether I need to print the variable I or not. Okay, so I'll check if my answer is equals to 1. What does it mean? If answer is 1, that means my variable I is prime. I is prime. Okay, so if I is prime, I need to display that. So I'll write printf. Okay, I just write %d is prime. Okay, so I'll just give a new line here, and after this I'll have to give comma and then %d is nothing but I. Okay, so I'm talking about the variable I or the number I. Okay, so this I will range from L to U, so it will pass through all these numbers and then check if I is prime or not. If it is prime, it will display that that number is prime. If it is not prime, nothing is displayed. Now finally I have got this main function. This is the driver code. Okay, from here I am going to make a function call. Okay, here also I am making a function call. This is a function call. Okay, so I'm just give it here. This is a function call. I'm making call to this check prime function, which is just defined before this function. So this is the end of all prime function. Okay, now I'm starting the main function. Okay, now main function would have this function call to all primes. Okay, so but before that I'll have to have this lower limit and the upper limit. So let me declare this variables lower comma upper. Okay, so I ask the user to enter this lower and upper limit. Let's scan this lower and upper limit. So now I need to find out all the prime numbers between lower and upper limit. Now it's very simple. We have already defined a function for doing that. The name of the function is all primes. So I just make a call to this all primes function. Okay, by passing the variable lower and upper. I do not get anything back as a return value, so I did not store this in any variable. I just make a call to all primes, passing the values lower and upper. Okay, this should print all the prime numbers in the range lower and upper. Okay, so let's try to first of all compile this code. So there is no error in this code. Let's run this. Now I need to provide the lower and the upper limit. Let's say the lower limit is 2 and the upper limit is 20. So whenever I press enter, what is going to happen is, okay, it is going to call to this function called as all prime. Okay, so enter lower and upper limit is coming from this one, that is from the main function. It will scan the two numbers and then it will pass these two numbers to this function all primes, which will help me to find out all the prime numbers between 2 and 20. So enter. So it says that 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17 is prime, and 19 is prime. Okay, it works fine. Okay, so what is happening in all primes is very simple. All primes is actually running a loop from 2 to 20. First of all, I is 2. It will check whether 2 is prime by using this from function check prime. If it is prime, it will display that the number is prime. Okay. Next time I would be 3. It will check whether 3 is prime. Next time I is 4. It will check whether 4 is prime. It will keep on doing this up to I equals to 20. Finally, it will check if 20 is prime. 20 is not prime. So this check prime would yield me the answer 0. So check prime 20 will actually transfer this control to this function check prime. This n becomes 20. It will check whether n is prime or not, that is 20 is prime or not. 20 is not prime, so it will return the value 0. Okay, so whenever 0 returns to this point, answer becomes 0. So if answer is 0, then this 20 is prime is not printed. So 20 is actually is not prime, so it is not printed. Okay, so this is how it works. Okay, you can try this with any other input. Let's say the initial number is 13 and the final number is 100. Okay, so all the prime numbers between 13 and 100 are listed here. Okay, so I hope you are clear on how to write a function. Okay, in this lecture we have learned how to write a function with multiple arguments. Right? In this case, see, there are 2 arguments, and you can have a function very well with arguments of different type. In this case, both the arguments are of type integer. And one more point to note down here is you cannot write it like this int l comma u, like you do the declaration of variables. Here you have to provide the arguments separated by comma. Each argument should have its own data type mentioned there exclusively. Okay, so this is how you actually give the argument to the function. Okay, we have seen a function of different return types. This is of return type void, and this function is of return type int. We have also seen how we can call one user defined function from another user defined function. So in this case, in all primes we are calling check prime, which is our own user defined function, right? So we are calling a user defined function from another user defined function, that is all primes. Okay, and finally we drive everything from the main function. That means we take the input from the main function and then we'll make a call to this all primes. So we say that this main function or the main code is the driver code for this entire program. Okay, I hope you have understood how function actually works. Okay, function is very simple. You just need to remember 3 things in a function, right? The name of the function, very important. You have to give a valid identifier name for a function. Give a name that is relatable, that is related to that particular problem statement, right? And the second thing is the input or the arguments for the function. Okay, while defining the function, you should make sure that you give the proper argument separated by comma. And finally, what is the return type of the function. Okay, if you know these 3 things, you can easily write any function. Okay, so that's all in this lecture. Stay tuned.